within the fascial network. And I think it's also interesting to note too, even if you look at the actual biomechanical properties of tissue, whether we isolate a particular tissue down versus in a whole form, and I know actually some of your research has looked at this too, you also see changes in the biomechanical behaviour that's typically non-linear. So like for instance, if you look at like the tensile properties of an individual collagen fibre versus a bundle, you would think that surely the
It's
bundle...
going to be a multiplier
in
in a linear fashion,
But you don't, you see a non-linear behaviour, and that's because of the extracellular matrix will influence the behaviour of the collagen tissue. And I know you've done some interesting stuff with looking at compressive forces of muscle in isolation versus a whole muscle or myofascial structure. And so I'll be interested to hear, well, one, some of your findings from that, but also two, how do we get around that? Like how do we get around teaching, particularly people who are really going to go into healthcare and clinical work, of making sure that they have an understanding that we need to make sure we're not overly reductionistic of the behaviour of tissue or the appearance of tissue, when in the human form it's actually very interconnected.